Okay, so we're reviewing for that quiz that we're going to have, or the test, whatever you want to call it, which is tomorrow on section 1.7, which is called modeling. Basically, I think of it as word problems. And there was a homework assignment last night, and one of the kids wanted to ask about number 4. Would you please read that to me? Wait a minute. Is half as long as the two equal sides? Go ahead. As function of the length of the base. All right, your first thought is I got to draw an isosceles triangle. And this is an isosceles triangle. I don't even need that line down the middle there, but I will in a second. And these two sides are equal, and this side is not equal. And that's the base, and that's x. If they say make it as a function of that base, I should call that x. Now, I know I could call that half x, but then it's going to make things much more complicated. So I'm going to just stick with that's x. And if this is half as long as the other sides, how long are these then? 2x. Do you have a choice of having a fraction or not? Don't have a fraction. It's easier not having a fraction. Next thing. The area of the triangle is base times height. I need to know this to proceed. So what the heck? Well, all of a sudden there's a triangle in the triangle. You see this? 2x on this side. X on, wait a minute, not x. What's this on here then? That's 1/2 of an x. And then that side I don't know, but can I figure it out using the what? Starts with the P. Pythagorean theorem. If you have 2 of the 3 sides in a right triangle, you should be thinking about this. All right, so now I'm going to stick in A and B and C. I'm going to call that A. And B I'm going to call the height. So A is 1/2 x squared. Notice I put it in parentheses. This is one of the most common mistakes on the test, is people do dumb stuff like this. They say a squared, and a is 1/2 x, so I'm going to put 1/2 x squared. You see what's wrong with that? The 1/2's not getting squared. You should really put an a with an empty parenthesis, and then drop in the 1/2 x, and now see that 1/2 will get squared, and it matters. Okay. Next up is plus b, which is the height of this thing. I'm going to call it just h for height, equals c, which is that side right there, which is 2x squared. Nobody stop me. There you go. Thank you. I was hoping somebody would stop me. Thank you. Okay. So now I'm going to get this h alone so that I can know what this is in terms of x's, like a whole bunch of gobbledygook with x's. Okay, so I got to subtract 1/2 x squared from both sides, and I will end up with h squared equals 2x quantity squared minus 1/2 x squared. Okay, and then I need the square root on both sides. B is equal to square root of all that junk. I guess I'll just write it. All right, and now I know what my height is, and now this part right here can go right there, and now I know my base of my triangle, which is x, and the height of my triangle, which is this awful thing. And there we go. All right, so that is number, what was it again? Number 4 off of the homework for today. All right, I also want to look at number 5. While we're on that sheet, look at number 5 with me. How many of you knew that this room, which is 3 longer than it is wide, should be x and x plus 3? Raise your hand if you knew that. Good. Next up, if I'm going to say that the total border around the room adds up to 54, that's a perimeter. So you should write the general form, 2 lengths plus 2 widths. Underneath that is where you start putting in the numbers. Some of you try to go too fast. perimeter is 54, so I can put a 54 here. 2 times the length. 2 times length is x plus 3, plus 2 times the width. Notice I put in parentheses even around that x. Just drop in empty spots wherever you have like variables like this and this. Put in empty spots like here and here. That'll keep you from making that dumb mistake on the test. I know some of you are going to do it. Okay, next up, I actually multiply it all out. 54 equals 2x plus 6 plus 2x. That's 54 equals 4x plus 6. Subtract 6 from both sides. 48 equals 4x. X must equal 12. And if you left it that way, I'd be so sad, but I'd mark it wrong. Because what did the directions say? Yes. Be careful with that. When you're all done with the problem, make sure your answer answers the question. And the question was, what are the dimensions of the original room? And if you said 12, that's not dimensions. That's a it's not dimensions. Anyway, so you need 12 and 12 plus the 3, which would make 15. And then if I wasn't sure if it should be like 12 and then 12 minus the 3, making it like 9, I would then, if I think it's 12 and 15, I would put them on here. And I'd add them all up, and they should add up to 54. That adds up to 30. That adds up to 24. 30 and 24 makes 54. It works. Then I can be really confident I did it right. All right, so there's a couple problems from last night's homework. Yes? Yes, if you had graphed this line and this line, y equals this, and y equals that, that's a great way to do it. And yes, on this part of the test, you'll be able to use calculators. All right. There's another part that you won't, and I'll show you more about that in a minute. In fact, this is it. Let's talk about this kind. Just some easy ones. These are like R2 questions, and you wouldn't be able to use a calculator because otherwise you just type this in and see what happened to it. You're supposed to know what's going to happen to it by looking at the picture. No, looking at the equation. Do you get that each of these things does something to my parabola? Do you get that there's only one right order? I shouldn't say it that way. There's actually more than one right order. But the right order, that there's only a few right ways to do it, and there's a lot of wrong ways to do it. The way I've taught you is you start on the inside, and then you do things in the opposite of the normal order of operations. And then you go to the outside, and you do it in the normal order of operations. All right, so let's do this one together. Would you please? There's obviously 4 things. 1, 2, 3, 4. Make a list of what happens in the right order. All right, I skipped over a little bit. I'm restarting the recording again here on one of the word problems. Just to clarify for kids that are watching only this video to get ready for this test, what I was talking about there for a second was about how to talk about moves up, down, left, right, that kind of thing. Like in this problem, if you were looking at this compared to this, that it's just moved over 2 more to the right, and it's moved up 7, and that's the order you do it in, because you start on the inside, do all of those things, and then go to the outside. And another like quick reminder on those kind of problems. Let me see if I can find them. Oh yes, if you were asked to do, sorry, kids that are sitting in the class right now, I just forgot, wasn't recording that, so take this. If you were asked to do what order it would be in, normally you do parentheses first, so since you're on the inside first, you don't do that. You do the opposite of the thing that would go first. You go the 2 first, and that would be not twice as wide, that would be half as wide. Second thing would be that it's right 5. Third thing would be that it's this and this to choose from, and the multiply comes first. When you're on the outside, you trust the order, so it's 5 times taller. And last step on this kind is up 1. All right, so that is the typical what order to do transformation kind of questions in. Those are like R2 kind of questions. All right, so back to, we were doing this one, and we're trying to find the area of the stars in terms of x. So first we got our picture drawn, we got our x's in there, and now if I'm going to try to do this problem, I have to have a formula. Do you get that I need a circle formula and a triangle formula? All right. Why don't you just give me your first shot at what you think the answer is? Yep, find the area of just the start in area. I'll give you this hint. It involves the circle being subtracted from the triangle. You think you're going to take the triangle and subtract the circle? Nope. Take the bigger one, subtract the smaller one. Otherwise you get a negative number. So it's just one last twist that some of you are going to catch and some of you aren't. All right, the area of that is going to generally be the area of the circle, which is pi r squared, minus the area of the triangle, which is 1/2 base times height. But there's one thing that's important that you understand. If I did that, I'd get all of these, like these little stars that are in here, it would be in this whole area too. It would be the whole circle minus the triangle. So that would include all of this out here too. So that wouldn't be right. Who can tell me one little tweak to make? Yes. All right, nice job. If you zoom in on just this part of the circle, you'd have 1/4 of your circle. You get that? That was a tough one. I don't think we'd have one that tricky on the test, but all right, so it's 1/4 of your circle minus the triangle. So now we need to put this in terms of x. Does this look like it only has x's in it? No, it's got b's and h's and r's. But in this case, it's really easy because the radius is the same as the base, which is the same as the height. So its area equals 1/4 pi, and I strongly encourage you to put an empty spot for each thing. Empty spot, because then when you drop it in, you won't forget to square. Like if there's a 1/2 or something that's going to go in here, you won't forget that that has to get squared. All right, so this is x, and this is x, and this is x. In this case, it wouldn't have mattered if I had the parentheses, but I'm telling you, it sometimes matters. Final answer, a equals pi r x squared minus 1/2 x squared. Okay. How about this? What's x times x? 1/2 x squared. Yes. Oh, I think I did. Thank you. Forgot to bring down the 1/4 right there. Sorry. And I have an r in there. Too. Weird. Yeah. 1/2 pi x squared. 1/4 pi x squared minus, yeah, now it's right. Whew. Okay. Now, let me just challenge you with this. What if this is the exact same problem, except it said that the area was 30? Well, I do the exact same thing, except what would I be able to add to my equation? Yeah, I'd be able to put a 30 right there. And then, how would I solve something as ugly as that? Graph it. Just graph the left side, y equals 30. Graph the right side, y equals all that junk. See where they cross. Make sure your answers make sense. What if one of the answers is -10? Can that make sense for the area of something or the length of something? No. And if it's just insanely big, like if just this area is supposed to be 30, and then you're coming out with this being like 9,000, I'd throw that answer out too. Because a lot of times you'll have extraneous answers, answers that won't actually work. So you got to sift through them and find the ones that work. Okay, let's do another one. Try this one. Should be able to do this one, and it comes out to a numerical answer. Like it's a single-digit number. Try it. Yes. Okay. Clarifying on the last one. You guys can work on this one if you want for a second, but okay. You actually can because they're both x squareds. The question was this. So we have, what was it again? 1/2, 1/4. Minus, they're both x squareds, but that would be really complicated because you'd have to take 1/4 pi minus 1/2, and without a decimal, you really can't do that. So no, just leave it alone. You would not have to, because that one's just too complicated to try to simplify. Okay, back to this problem now. This problem. Generally, you want the area of this, where the smiley faces are. What the point here is the shaded region like in here. I just didn't want to do the shaded region again. But, okay. I've really scribbled all over the smiley faces. I hope that's not bad luck or something. All right, so the isosceles triangle, which means this must be the same as this. Notice it can't be this one. That can't be 5 because in a not an isosceles. In a right triangle, the hypotenuse has to be longer than the other sides. So it can't be that one. So this must be 5. I hope you already labeled that on your picture. The next thing you notice is that it's twice as wide as the circle. That means the circle is 2.5. But that's not the radius. The radius isn't 2.5. What's the radius then? 1.25. And that's important to note. Once I had all that drawn on my picture, I'd probably figure I was done with my picture. Now I go and write my equation. Area of the smiley regions, which is the shaded region, is triangle minus the circle. And the area of the triangle is 1/2 base times height minus the area of the circle, which is pi r squared. And I know all those numbers. 1/2 times 5 times 5 minus pi, which is a number, times 1.25 squared. And then if you do that in the right order, which your calculator can do for you if you want, just type it exactly as you see it, you get, isn't it 7 point something? So I'm going to show you, I think I still have that on my, there it is. From last hour I typed it in. I put in 0.5 instead of 1/2. 5 times 5 is 25. I used the pi button, which is right above the caret key, and all right there. I would just use pi unless it specifically tells you otherwise. There's the pi button. Okay, so 7.59. Does that seem reasonable? Well, if the area of this whole thing is 25, and we like take away some here, and we don't have this here either, then yeah, I'd say it could be 7. That seems somewhat reasonable. If the answer had come out to be like negative or really huge, I would be skeptical and think I'd done something wrong. All right. Now, here's how you can make this problem more of an R3. That was actually like an R2. That's pretty easy to just stick those numbers into the little equation. How about if they do this? What if they say that is x? And what if they say shaded region is 40? Tell me what you'd write for your equation now. It's very similar. All right, so now I'm saying the area of the whole thing of the shaded would be the triangle minus the circle again. So the triangle is 1/2 base times height minus the circle is pi r squared. All right. So this base is x, the height is x. 1/2 x times x minus pi times, it's not x though for the radius, is it? It's not even 1/2 x. Because a 1/2 x is what this would be. So from here to here, that's 1/4 of x. Notice I put my parentheses, because if you don't have the parentheses, you'll get it marked wrong, because the 1/4 would not get squared if it wasn't for those parentheses. And then that's all equal to the area of the shaded region, which they told me is 40. Now I can graph this side, see where they cross. How many of you followed that? You understand where I was going with that one? Okay, good. All right. So now, a box, the classic box problem. You've seen it before, you'll see it again. So, would you draw me your rectangle with your little corners cut out? We're going to pay special attention to this part. What is the domain? Because we don't want you giving us answers that are impossible. All right, so 36 by 24. Corner cutout. Corner. 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 Actually, erase these parts. Okay. My picture look all right? Okay. So now I need my formula. Formula for box. Volume. Length. Width. Height. Do I know the volume? Does it tell me the volume anywhere? Yes, it does. 90. 90 equals. Do I know the length? Don't say 36. I'll have to beat you with a wet noodle. Yes. Yes. The width. 24 minus 2x. And the height is x. Now, you graph this side. Graph this side. Everybody, on your graphing calculator, I want you to see what kind of problems you're going to have with this. The main problem is your window. You're not going to be able to see where they touch at first until you play around with your window and you do zoom 0 and zoom 6 and I don't know, all kinds of different zooms. Maybe you even go into your window and start manually adjusting it. All right. Now I knew that I had to go up at least 90 on my graph. So zoom 6 is not going to be nowhere close because it won't go. Zoom 6 goes up to 10. So if I do here, I'll do what I had to do. I'm going to go to zoom 6, and at first you don't see anything. So then you got to zoom out, see if you can find something. So I'm going to hit zoom out. You have to hit zoom out a couple times. You have to enter twice so that you can see in your picture. Did I hit enter more than twice? It's taking me a long time. If you ever have this happen where the calculator's kind of stuck in that mode, if you hit the on button, it stops it. So I'm going to go back to window and see what window I have here. Negative 40 to 4, that should graph. I think graph. There we go. Okay. Now at least I can see a couple lines. Now I'd have to say, all right, I got to go up at least as high as 90. So then I'd go to my window, and up 90 means Y has to be 90 or more. In fact, let's make it more like 100, 110 or something. And now I can see where those two things cross. If I wanted to get even better, I'd go zoom box. Zoom box is that top one. And then I'd just kind of box in part of the graph where those two lines are touching. Well, that didn't help that much, but okay. So now I want to do second, calculate intersections. Whoa. I don't know what just happened there. I'll go back to my graph. Second, calculate. Intersect is number 5. Okay, first line, I'm on it. Second line, I think it's on it. And it says guess. Well, I need to like arrow over until I think I can see the spider again and know that it's fairly close to my. All right. Dang. That's one problem with being zoomed in so far. You know what? I can just hit enter and it will pop up on one of them. See, it popped up on that one. It could have popped up on the other one. I don't even know which one I was closest to, but I know that it'll tell me both of them. I mean, it told me where it was, and it was closest to these two. So that spot where they put the spider is 11.69. The other spot, in case you went there, is like 17, or did I make good there? 18? Okay. So one of these spots is 11.7 and one of them is 18. Now, here's the really important part. Pay attention. Only one of these two is right. I can tell which one. You look at the domain of your picture and you say, wait a minute, 18? If I make a cut out of here that's 18 inches long, do you see how I won't have room to cut the other corner out to be 18 inches? That's too big. In fact, what is the domain? What is the smallest x could be? 0. And could it even be 0? No, because then you wouldn't be cutting anything out of the box. All the way up to what's the biggest that x could be? 12 in this situation. You'd have to tell me that. What is the domain? It's 0 to 12, and it can't be 12. Now, when you look at your two answers, only one of them, 11.69, is in that range. So that's the answer. The other answer is too big. It wouldn't work. All right, so some kids are going to be smart enough to get the answer, but not be able to tell which of the answers they got is wrong. All right, so 11.69, and I would just cry for a kid who goes this far and then does that and gets it marked wrong. Why would that be wrong? Because what does it actually ask for? The actual length and height and width. Length, width, and height of the box. That's not the length, width, and height. That's the height. So then I'd have to go back and figure out the length and the width. The length was here, width was here. I just stick this into there. And now that you know that you want all three things, it won't be hard to get. The height's 11.69. The length and the width you can calculate out. And once I had my answers, I'd double check them. I'd multiply them all together, make sure they make 90. Because then I'd know I have it right. So check yourself. It's really, really important. Okay. You could do all that work and then get nothing for it if you don't just read the last part. All right, so what would I do now? If I were you, if you have not already finished all the homework problems, I would do that, and then I would check them against the keys, which are supposed to be posted tonight. Next thing I would do is I would make up some, if I needed more practice problems, I would make up your own. I'll make some up with cylinders. I'd make some up with rectangles that are twice as long as they are wide, you know, that kind of stuff, and then the area of it is 70, and then, okay, you could make it with, we've done a bazillion box problems. You can make a box problem for yourself. Try to think of a real world situation. It's like, you picture how big the cardboard is and like, okay, well maybe it's like 40 inches by 10 inches and I want to have it hold this golf club that's going to be about this many cubic inches. Make up your own one of those. Here's one more you might want to make up. Length of string. Remember this one? Cut into two pieces. If this is X, how much is this? Well, we'd have to know how long the string was. Let's say the string, I think the problem we had was 14 inches. Then what would we put? 14 minus x. And let's say this part forms a circle. Let's say this part forms a square. Well, this circle, if all the way around it is x, then how far is it across it? Well, you'd have to set up like this. Circumference pi times d. And then this, if this 14 minus x all the way around, then divide that in 4 parts because it's a square. 14 minus x over 4 for both parts. And then you could say, like, what's the sum of both of them, their areas? Or if their total area was 12, then how long is x? That kind of stuff. So set up some practice problems for yourself. You can do that. And if you really want, you can come in the morning, and I'll be here. If you're feeling lost, I'll be here in the morning. You can get extra help because it is a Tuesday tomorrow. Yes. Yep, I can put the box problem back up. A question about it, or do you just want to leave it up there? Okay. Do not worry about number 6 on the worksheet. That it was too hard. You will not have anything that hard. Yes. You do need to know the cylinder equations. I will remind you of them. For a cylinder, you're talking volume, pi, r squared h. And I doubt we would make you remember the surface area formula. But if you did, it's 2 pi r squared, which is 2 circles, plus 2 pi r h. Obviously pretty similar to each other. Okay. Any other things you want to know? All right. Answers should be online tonight. Check them. This is going to be a harder test. The first part of it is all that stuff about moving, shifting, doing it in the right order. I think you can get those right, and you'll get a C. You just had to get 3 out of 4 right. I think you're pretty likely to do that. Then, out of the word problems, I've shown you many kinds. Do you think that you could answer at least half of the kinds I showed you how to do? The one you got to beat. Okay? Just don't make some of those dumb mistakes. Like I was reminding you, when you put in a variable, you got to put in a parentheses to drop your number in. If it's a variable, that's an empty parentheses. Drop the thing in there, and then you won't forget to square the whole thing. And I've given you so many pieces of advice, I can't sum them all up right now. I guess biggest picture is always that comes down to you have a picture, you label it, you get an equation, you stick the info from your chart into the equation that you got, and you solve it from there. On the graphing calculator, it'd be handy to have because you're going to use those on the R3s. Probably can't on the R2s. Any other things you want to know? Okay, that's my best advice. I think you can pull off a B on this if you can keep from making dumb mistakes. And A's, some of you will be able to pull off the A's too. I mean, you all could get the A in theory, but it's going to be tougher on this one.